always happens. Got it. So I'm a physical scientist, work with social scientists. I talked about single hazards, anthropogenic processes, and also I look at hazard interrelationships. The last 7 years I've been working in India, Philippines, UK, Kenya, and Turkey are various places that I've been working. And just brief bio, I have a physics undergrad degree, then did geophysics, and now work a lot more with physical scientists, social scientists. Just a note for the students in the room, these slides have already been made available to Pete. Pete is going to upload them. In general, for seminars, we will upload the slides after the seminar, and that would be a typical way to do seminars. So the Institute of Hazard, Risk, and Resilience, we're one of 10 research institutes at Durham University, and we cut across the 27 departments that are at the university. So many of you are studying within geography. Those people online, I'm not sure. I think there are probably other people who have decided to join. And we generally try to engage and work with the departments for research, for outreach, et cetera. And so the Institute of Hazard, Risk, and Resilience, we are almost 20 years old. We take an interdisciplinary approach to understanding hazard, risk, and resilience. And during these first few weeks, for those of you who are master's students, you will become more familiar with these terms of what we mean by hazard and resilience. And what we're trying to do is to actively translate research into practice. Think about what does that mean in terms of practice. So we have a broad range of sciences that we work with, physical sciences, art and humanities, et cetera. And we're flexible in terms of research grants and outreach. So as an example, Ellen here is a postdoc within the Institute. She's been doing work in India, Nepal. I just got back from Philippines. Ellen is an engineer, and she has been working on engaging a large variety of actors to do with road slopes and potential for risk and for cascades, for mass wasting with them. So there's a number of postdocs. We have directors, myself, some managers, and so we have a general community thinking about hazard and risk. So we think about forecasting hazards, and by hazards, we talk about earthquakes or floods or war. These are different types of hazards. Understanding risk, and when we talk about risk, we're talking about not just the probability of something occurring, but also the vulnerability of the people. The physical vulnerability, how buildings are made, the exposure, the roads, the buildings. So all of these are going to combine to become risk. And then crafting resilience, so the ability of a community or a system to bounce back, basically, to withstand the shocks or the crises to the system. We broadly are broken up into understanding single and multi-hazard risk for strategic planning, tools and methodologies, adaptation, resilience, recovery, and social equity. And I'll leave this for you, but this is typical. What is a hazard map? Forecasting different types of hazards, going to what are things like virtual reality or web-based platform or tools that we might use, the data flows that might be conflicts when we're thinking about risk, climate adaptation, short, medium, and long-term recovery following disasters, resilience of food supplies, of the NHS system, and empowerment strategies for marginalized groups. So there's quite a bit of news we have on our website, so I encourage you to visit it. We've had over 150 master's students go through the Risk Masters. Many of them identify the hazard and risks and resilience themes that are part of the Institute. So we're going to focus here on one aspect of this broad range here in our vision. And this is on, we're going to look at multi-hazard risk scenarios. And at the end of today, what we'd like people to be thinking about is what is an interrelationship between successive hazards? What does that mean? And why should we care? Those are the sorts of things that we're thinking about. So multi-hazard interrelationships and dynamic risk scenarios is what we'll do today. And I'm going to start with single versus multi-hazards. So if we take a single hazard, we can take examples like landslides. And this is Shinmo in China, and there were 83 fatalities. And volcanic eruption. This was in Java in Indonesia, and I was in Indonesia a couple of weeks ago and talking with their geophysical climatology arm of their government. And this is hail in Sydney, Australia, 12,000 insurance claims, and flooding in Gujarat, India, 130,000 people. So we have hazards. Sometimes we have impact. In these cases, we did have impact that occurred. And these are examples, and you can think of many other examples of single hazards that might occur. And I'm just realizing where the camera is. And the camera is right around there. Okay, so it's a new camera, so I'm now trying to figure out where that is. So if you want an up-to-date kind of what are the current disasters happening in the world, I looked at this today, and there's 5 currently on its list. There's the Nepal. I'll just magnify this. Nepal floods and landslides. There's Central Europe floods in September. Kenya, there's a polio outbreak. Algeria, there are floods, and there's a Typhoon Yagi that is happening right now. So this was looking at the past month at just what kind of disasters. And this is something you can always go to reliefweb.int disasters if you're curious about current disasters that are occurring. So let's take single hazards. And we're going to think broadly about single hazards here. We're going to break them up into 21 categories. Now, this is work that I did with when he was then my PhD student. He was the first year PhD student. And I said, let's do a literature review on multi-hazards. And neither of us had worked in the area before. And of course, as often happens for PhD, what was supposed to be a simple literature review became 1.5 years of his PhD thesis and a paper. So what we did is we tried to break up and think across all different hazards. And we went geophysical, hydrological, shallow earth processes, atmospheric, biophysical, and space. And we looked at many existing classifications at the time. And I'll come back to this, but this ranges from earthquakes down to tornadoes and hailstorms, extreme temperatures, and geomagnetic storms. So if you have sun flares coming out and what might happen from those. And these are actually high on the UK's potential list of hazards that might cause impact, because they'll disrupt a lot of the radio waves, the aviation waves. So we're quite worried about those and impact. So we'll come back to this. This was a classification we did 10 years ago. Now there are other existing classifications. So for instance, at the United Nations level, something I recommend that you visit, they put together 300 and I think 13 profiles of hazards. This is only launched in the last couple of years. And they're trying to get all countries everywhere using these detailed hazard information profiles. So they're called HIPs, and they're at the United Nations level. So this is just to remind you, when we talk about single hazards, earthquakes or floods or tornadoes, it's not just the big ones that we're thinking about. There's also medium ones and small ones that occur. And so if we look at the spatial scale here, so this scale is on a logarithmic scale. So we're going up by orders of 10. So this is 1 square kilometer, 100 square kilometers, 10,000 square kilometers. So we're going from the micro to the global. And on the y-axis here is time, going from seconds all the way to millennia. Again, orders of magnitude. If we just take something simple like a flood, floods can last from hours, in a couple hours, it's there and it's done, all the way to months. We can have flooding, and they can go from 1 square kilometer from very local to regional to 100,000 square kilometers. So we start getting very big. And you can start thinking of the footprint of each of these hazards. Generally, we have many more medium ones and even more small ones of a given type of hazard that might occur. And so we've talked about single hazards. Now we want to move to multi-hazards. So multi-hazards, there's 2 major ways of thinking about it. One is a multi-layered single hazard approach. 95% of organizations, when they say multi-hazard, are talking about a multi-layer single hazard. And what they'll do is they'll take hazard A and hazard B and hazard C and hazard D. They'll put them into a geographical information system, and they'll lay them on top of each other and add up the risks. And that will be their hazard profile. Now, another way that is becoming more and more common to think about, but only over the last decade, are multi-hazard, where we think about the interrelationships between the hazards. So what is the interconnectedness, the interacting, the interrelationships between hazards? And that's what we're going to be focusing on today. This is just an example of the multi-layered single natural approach. We have earthquake total risk and landslide total risk and flood total risk. This is from Australia. And they just add these up and say, these is now going to be our total risk. This is the Philippines. I just got back from the Philippines on Saturday evening, and I was working there with their Resilience Institute, which has about 90 people in the institute. And they are largely on the multi-layered single natural hazard approach. Project NOAA is, I think, one of the most impressive in Asia for taking single hazards, overlaying them in a GIS that is for the public facing, that the public have access to. It's a really interesting website to visit. A lot of money has been put into this and a lot of resources. So multi-hazards is a holistic approach, interconnected, interacting, interrelationships. And there's a large amount of literature on this. This was a table done by Philip Ward in 2022, summarizing projects. There's now quite a few major European projects, not as many UK. It's still not really focused in the UK, although it's part of many calls for research funding, thinking about multi-hazard and interconnectedness. And by the end of this talk, hopefully you'll better understand what we mean by interrelatedness, interconnectedness of hazards. I should say, for those of you who are master's students, I was at King's College London for 23 years before coming here about a year and a half ago. And I'd say I've had at least 10 different master's students who ended up doing projects related to multi-hazards for a given region. So it provides a lot of fodder depending upon, you can always do engineering, or you can do it from a physical, or you can do social sciences or a business aspect. There's all sorts of things that you'll be able to bring into this. So what does multi-hazard mean? It means the selection of multiple major hazards that a country or region faces, and the specific context where hazard events, and this is the important part, they occur simultaneously, cascadingly, or cumulatively over time, and taking into account the potential interrelated effects. This was from 2017. And so we're going from thinking of hazards as discrete and independent to thinking about the interrelationships, the interacting, interconnectedness between the hazards. So I'll just give you some examples. So this is an example, and I like this one. I purposely use a really old one because I love looking at the past and going into geomythology or into legends or artwork or ceramic work for thinking about what has occurred in the past thousands of years ago, sometimes to tell us about the future. So this is an example of a volcanic eruption triggered a landslide, triggered a tsunami. And this was in Japan. 15,000 fatalities from this, a third from the landslide, 2/3 from tsunamis. By the way, whenever anyone says this is the number of fatalities, always take this with a grain of salt, because they're always guesstimates when we talk about the number of fatalities. Another example, again, Philippines, is a volcanic eruption triggered earthquakes and global cooling in 1991. But at the same time, the volcanic eruption was coincident with Typhoon Yunya. It occurred at the same time, but it impacted the same footprint in space and time. And so you got the combined effects with Typhoon Yunya triggering lahars and triggering floods. And so you had a combined effect of multiple hazards occurring at the same time. We can go through lots of other examples. This is a rainstorm triggering a landslide, triggering a flood. You can get another one. I'm just going to pick out a couple here. I've given a number of examples here. This one, an earthquake triggering collapse of loess deposits, and the loess blocked rivers and triggered floods. This is actually what got me started thinking about multi-hazards about 12 years ago, was there had been some particularly devastating events that came out of China, which was an earthquake. It triggered landslides. And then weeks later, the landslides had built up in the hills, the sediment from them, rain came along, it washed it down into the valley, and it ended up blocking rivers and causing many, many fatalities. Now, what the hazard managers at the time in China, and we visited China after some of these, they were not thinking earthquake, there might be a flood. They were thinking earthquake, and in the most extreme example, they were saying earthquake, landslide. So they hadn't yet brought that into their thinking. And the reason is that often in the hazard community, we're very siloed. The earthquake people work over here, the flood people over here, the meteorology people over there. So we're not always talking with one another. That's very slowly changing. And that's really what triggered me thinking about multi-hazards and whether we could start bringing together our knowledge on single hazards to better understand the interrelationships. Now, many examples here, ranging from earthquakes to warm temperatures, causing snow melt, causing landslides. And we can keep going through many actual examples. But why are multi-hazards important? So first of all, if we treat the hazards as being independent, it might distort the management priorities. And a good example was the Turkey-Syria earthquake that occurred recently, is that occurred at the same time that there was a cold snap. And I told you some of my research has been in Turkey, and I had actually asked 5 or 6 years ago to the team who does earthquakes there, well, what happens if you have an earthquake and something else? Oh, well, we don't worry about that. We're just focused on the earthquake part. And so that was something that hasn't been brought into kind of the profiling and the hazard managers in Turkey, thinking about, well, we could have the earthquake, but what else might be occurring at the same time? Or if we have an earthquake, where do we move people? You don't want to move people then into a flood-prone area. And so these are thinkings about the different hazards. So it might distort management priorities. It might underestimate the risk, the vulnerability can increase. It can increase vulnerability or exposure to other hazards. And we'll come back to this idea of the dynamic nature of risk. So understanding the multi-hazard dynamic can help us improve the risk reduction, the planning, and the response. Now, I gave a talk similar to this in the business school a few months ago, and I was thinking, well, what happens with the business side of things? And so I did a quick Google, and these were just some examples of recent papers where the business community is now very much thinking about multi-hazards, and they're thinking about the supply chains. How do we plan for them? The economic resilience of organizations under multi-hazards. So there's actually increasing numbers of multi-hazards in the business community. So in the rest of this talk, I'm going to focus on hazard interrelationships, anthropogenic processes, dynamic multi-hazard risk scenario. Each topic can be extended quantitatively and qualitatively to include environmental, economic impact, social sciences influences, and better understanding of resilience. So let's move into natural hazard interrelationships. So this was a paper we published 10 years ago. It was the first paper of my PhD student, Joel Gill at the time, who's now a lecturer at Cardiff. And we started with, well, this was after months of working, but we will start with a grid. And on the y-axis, we're going to put primary hazards, and it's going to be the earthquake and tsunamis and volcanoes and landslides and all the single hazards that I gave you before. On the x-axis, we're going to repeat all of those single hazards. And then what we're going to do is we're going to look for any potential hazard interrelationship existence between pairs of these. And I'll show you examples. So these are the different hazards again, the earthquakes, the floods and droughts, the regional subsidence, the storms and tornadoes and lightning and extreme temperature, wildfire and geomagnetic event. And so we come back to this, and for every cell, what we want to look for is there a potential interrelationship? So for instance, earthquake, landslide. Yeah, earthquakes can trigger landslides. There's a lot of literature on that. Earthquake. Can earthquake trigger earthquakes? Yes, we know that can. And so we're going to look at triggering relationships where an earthquake might trigger a landslide. And by triggering, what we mean is there's an energy influence. And so it generally is a causal relationship where the energy from the earthquake is transferred into the system and the landslide. So here we get the shaking of the earth, and so we end up with landslides that are triggered. We're also going to look at increased probability relationships. And what that means is that the primary hazard preps the environment such that the secondary hazard might be more likely to occur. And so an example would be a forest fire. What happens in a forest fire? We harden the ground. This makes it more difficult for rain to infiltrate. We get rid of some of the vegetation. So weeks or months later, when rain does come that's hard enough to break through this top layer, we can have some devastating high mobility landslide movement. So they're basically forest fire triggered landslides, which are often not in the common thinking of many people. And so what we'll do is in the top left, we will shade the cell if it's a triggering, in the bottom right if it's increased probability, and shade the entire cell if it's both triggering and increased probability. I'm also going to use a light gray and a dark gray just to indicate how many of an event might be triggered. So an earthquake can trigger one or hundreds of thousands of landslides, depending upon the environment. But an earthquake will trigger just one tsunami. And so an earthquake triggering one tsunami will be there, and earthquake triggering many landslides, the potential will be a dark gray. So here we now have done this, where we've gone into every cell, not me. This is what we have PhD students for. So they did the work. And every single one of these cells looked for evidence. And behind this table is a very extensive spreadsheet of data and information. And so every one of these is backed by evidence and literature and comments on what the relationship is. So I'm just going to give you some examples here. So here is a landslide triggers a tsunami. So we fill in the upper left. Here, a volcanic eruption can both trigger and increase the probability of a landslide. So we fill it in. And so then we can say, well, a volcanic eruption can trigger many other hazards, and they include earthquakes and tsunamis and landslides, snow avalanches, flood, lightning, extreme temperatures, and wildfires. Some of these are very intuitive, some of them are not. And this is where we really want to get at. What is intuitive, what is not? For the existence in each of these pairs, primary single hazard could then result in a cascade of hazards occurring. Landslides being triggered, they can be triggered by earthquakes, by tsunamis, by snow avalanches. One that I had not thought about was hailstorm. It's not just the weight of the hail, but also the liquid from the hail will result in potential landslides, snowstorms and storms and ground collapse. And so we have examples there. By the way, I've thrown in the lower right-hand corner some graphics. These are from ChatGPT, where I threw in the words and I said, could you give me some figures? I have acknowledged ChatGPT here, but it is very interesting what ChatGPT can now do, the paid version. So it can do some rather interesting graphics here. So another example here, and now we can start seeing it, is volcanic eruption can trigger a landslide. The landslide can trigger a flood, and the flood can trigger ground collapse. So we can start visualizing the cascade of hazards occurring here. Another example here is storm here triggering a flood. The flood can trigger a landslide, and the landslide can trigger a flood here. So that's on single hazards. If you're interested in the multi-hazard interrelationships, if you're interested, there's an extensive paper which goes into much more depth on the multi-hazard interrelationships. I'm briefly going to talk about anthropogenic processes, and then I'll be spending a little bit more time on dynamic risk scenarios, and then we'll wrap up for questions and comments. So let's move to anthropogenic processes. So these are intentional human activity that's non-malicious, but might have a negative impact on society through the triggering or catalyzing of other hazardous processes. This is our definition. We did it after looking at the literature, and we decided we preferred it to human-induced hazards or many others out there. And so what we did is in the first part of the talk, I talked about primary natural hazards triggering or increasing the probability of secondary natural hazards. But we can also have technological hazards and disasters. So that would be like a dam break, would be a building collapse. But you can also have anthropogenic processes, and we have examples of all of these. There's another paper from 2017, if you're interested in reading about this. And by the way, there are a number of PhD theses and master's theses that have been just done on the theme of anthropogenic processes. So I'm going to give you a very kind of Cliff Notes version of this. I think Cliff Notes is in the UK. Is Cliff Notes in the UK? No, there's an equivalent. It's the 2-page summary of a book that people turn to. Actually, now they look at the YouTube video summary of it. There used to be the 2-page summary of a book that you would read for your report instead of reading the book. So we're going to take anthropogenic processes, and like natural hazards, we're going to subdivide these into groups. And so we're going to subdivide these. I'm just going to get the magnifying lens into subsurface processes, surface processes, and subsurface and surface processes. And so we're going to think about material extraction. So that could be groundwater or oil, gas extraction, subsurface mining, material additions such as fluid injection. When we get to the surface processes, we can think about land use change, such as vegetation removal, urbanization, and you can keep going and try to break up and think through all the different anthropogenic processes. And so what we want to do here is we want to look at all these anthropogenic processes and ask, is there an interrelationship in potentially catalyzing or triggering a given natural hazard? And so we take the 21 natural hazards we had before, the 18 anthropogenic processes, we create ourselves a matrix. So on the y-axis here are all of our anthropogenic processes, on the x-axis, all of the natural hazards. And the potential number of linkages before we had 21 times 21, so 441 for the natural hazards. Now we have 378, and for every one of these, we'll look for potential linkages. So an example would be groundwater abstraction can trigger earthquakes. We know that quite well, that if you extract water from the ground, that you might potentially trigger lower magnitude earthquakes, not the really large ones. Or oil and gas extraction, the waste from that can trigger regional subsidence. And we can also not just talk about pulling it, but pushing it back in, and the ability to cause earth on those. So what we found were 57 anthropogenic processes, natural hazard links, and we started looking at those. We told a story about them of what you might expect. But what is interesting is this is an example of vegetation removal can trigger landsliding, but each one of these can then result in a cascade of hazards that might result. And so what we could start using is thinking about these anthropogenic processes and how they amplify, or they might de-amplify, normally amplify the process of certain hazards becoming larger or smaller. This is starting to think a bit more holistically, particularly in urban areas. And this is where we're going to move to for the last major part of the talk, is dynamic risk scenarios, where we're going to focus on urban areas. So this is the result of two recent papers, the last couple of years of work. The paper on the left here was actually published just in August. So it's a recent paper, and I was pleased today because the paper on the right for Kathmandu was accepted for publication today. So it's very recent. So what we're looking here is now we want to go from the global, and now we want to focus in on individual cities. And this was part of Tomorrow's Cities, where it was an £18 million grant led by Edinburgh. And it was thinking about not about today's cities, but how do we plan for cities 10 years, 20 years, 30 years from now? What is it that we can talk with planners now about that might influence the cities of tomorrow's, thus the name Tomorrow's Cities? So I'm going to talk a little bit and give you a synopsis of some of what we found for this. And what we did is we first identified all single hazard types that might influence Istanbul, Nairobi, or Kathmandu. There were 3 different teams working over the last couple years. I'd say the last 2.5 years on this project. And we used for evidence for the single hazards what I call blended sources of evidence. And these include peer-reviewed literature, but also gray literature. So that might be government reports, call-out data from like the Red Cross, newspapers, social media, databases such as Desinventar or EMDAP, and expert input. when we were done, if we put all of these together, we had over 190 sources that we went to, that we systematically used and categorized. And I'm just going to show you a little bit the degree with which we were classifying. So every hazard interrelationship, we look for the following. So this is just for the single hazard, sorry. We broke it up into the hazard group, type, code, component hazards that might occur. So for instance, for earthquake, there might be ground shaking and ground rupture and liquefaction. We're thinking about what are some of the component hazards, the source information, the source content, the hazard interrelationships and anthropogenic influence that might occur, and then video evidence, because we knew that policymakers might be using this. And so we wanted them to be able to click on videos, say, here's a landslide, here's an earthquake in that particular area. Our reflections on hazard, how big might it occur over a given period of time, and other reflections. And so from that, what we found, and I'll just break this up, is here we have all of the hazards listed again, the single hazards from before. We've added a couple, and these were based, we worked with local people in each of the city, local scientists, to make sure we were getting our story right, and we were working together on this. So we added SAISH, or SAISH, I never know how to say it. Someone can correct me. So we worked with people in Istanbul who asked us to add SAISH and fog. Nairobi, they actually asked us to add urban fire because of the importance of urban fire. Interestingly, I gave this talk in Philippines a week and a half ago, and there was strong interest there because they're just opening up, really thinking about urban fire in Philippines and how that might work. Now, the key takeaway here is that the whys here are yes, we found evidence for it occurring. And means no. Now, this is probably the first real takeaway here, is we found a breadth of hazard types. And when we presented this, I'll show you in a few slides, we worked with stakeholder groups from each area. They were surprised at the breadth of single hazard types that occur in their region. And it really got them thinking about, wait a minute, we didn't think that all of these things occur. So for an example, earthquake, when I first went to Nairobi, and I've had a few different projects there, they would say, no, we don't have earthquakes. And finally, I realized and asked the question, do you have tremors? Oh, yes, we have tremors. So sometimes it's about the language that you're using and explaining what you mean. So we were working quite closely with them. So we then systematically noted two types of potential multi-hazard interrelationships, the triggering and the increased probability. So an example, this is from Turkey, storm triggers landslides. And we found various sets of interrelationships for Istanbul, Nairobi, and Kathmandu. Some of them were theoretically possible. Others we found direct evidence for having occurred in the past. And so we put this on a 24 by 24 cell matrix because now we have 3 more. This is an example for just Istanbul. Out of 576 possible, 106 potential hazard interrelationship. So again, we can show this example of cascades occurring and what might occur. Now, what we can do is we can extend the hazard interrelationships to dynamic risk scenarios that include the anthropogenic processes from the second part of the talk and consider how urban areas might change for the future. So let's take the earthquake. And the reason why we came up with this alternate way of visualizing is we realized we were going to be talking with policymakers and practitioners, and we wanted to make it as simple to visualize as possible. And so we said, there's an earthquake, so we're going to go from the matrix, and now we're going to visualize it in a graphic. So earthquake to tsunami can trigger a landslide, can block a river, which causes flooding. Another example would be a heat wave can trigger drought, which causes wildfire and local soil subsidence. And there's an infinite number of, actually it's probably, no, it is infinite. There's an infinite number of cascades that you could pull from this matrix into potential scenarios. But now we want to think about those these scenarios. So now we have two examples of scenarios. And what we want to now consider is, what about hazard, exposure, vulnerability, and risk? And so for those of you on the master's module here, this is something that will be key through a lot of your thinking throughout the program, no matter which program you're taking. So the hazard is the potential magnitude of the hazard, including probability of a given size in a defined period. The exposure are the human assets that we might have, like housing and roads and buildings. And the vulnerability are the conditions either of the social vulnerability would be the people, the economic impacts, so the age, the gender, the ethnicity, the illness, the disabilities. This would all be social vulnerability. Physical vulnerability would be, how is the building made? So we contrast the physical and social vulnerability. All of these are adding up. And what we want to do now is we want to overlay these ideas onto one of these. So we take our example of earthquake, tsunami, landslide, and flooding. And if we think of an earthquake before and an earthquake after, the exposure is very dynamic, it's changed. It doesn't just change for this, but this is an example. What this means is if a hazard manager has made a hazard map just based on earthquakes, the exposure for that will look very different before and after. And what this means is you can't have static risk maps for earthquakes or landslides. You need to think about the other hazards that might result. Because what will happen in the earthquake is roads will shut, buildings will collapse. And so when the landslides come along, they're going to see a very different potential susceptibility to landsliding. And the risk of from the landslides will be very different. Anthropogenic processes can highly influence these dynamic risk scenarios. So if we take an example, on the medium time scale, vegetation removal can increase the severity of this drought. On the longer time scales, human-induced climate change, actually any climate change, can influence the magnitude and the severity of the heat waves. And so we start bringing all of these together and thinking about how they might impact. So what we did is we actually presented these slides in this section to practitioners. And in Istanbul, we did workshops, 2.5 hours. In Nairobi, we did workshops. And in Kathmandu, we did workshops. And so each one of these took quite a bit of time to organize, make sure we had simultaneous translation for Turkey, etc. And what we asked them were two things. Actual output after we were in. First of all, what multi-hazard scenarios can you think of? And so these are examples of scenarios that the Nairobi participants and the Istanbul participants put together in discussion. This was one of the things. And so this is an example of two multi-hazard dynamic risk scenarios created by Nairobi practitioners. And what's interesting is, and this we had not thought about previously, including those who were local on our team, was the factor of flooding causing urban fires. And it's really clear when you go into the urban areas, into the slum areas in Nairobi, you'll often see the electricity from the informal settlements is illegally attached to the poles. It's very loose. It hasn't been tied down. So anything, big wind, flooding, it ends up going in the water and ends up causing more urban fires. And so there's a real concern about the urban fires there. The second thing, we spoke for about a half hour with them in small groups and bigger groups about what are the challenges and opportunities in incorporating dynamic multi-hazard risk scenarios and planning into policy and into practice. And so they identified a number of things. They talked about the very siloed natures and approaches to hazards within their own communities. They talked about lack of enforcement of regulations, and they talked about a number of other things. Opportunities, though, is really increased awareness of factors that might influence and dynamically influence their urban region, how they might integrate these into current urban planning projects, which is what we were really trying for. So just in summary, so the previous slides focused on these 5 papers here. There are other papers we've done as part of a larger group that I've worked with over the past 10 years. And just a couple to signal. This one was led by an Italian. She was, at the time, this was a chapter in her PhD. And this was looking at a framework for now, not the hazard, but the impact, and thinking about spatial temporal impact analysis. We also, all of the slides previously have focused on the existence of hazard interrelationships, not the quantification. And so with other groups, I've been working on the quantification. What can we learn from one field with another one? So the earthquake community, we know about the relationship between earthquakes and landslides, and we have basically an empirical relationship. There's also deterministic relationships that we can start bringing into our thinking of hazard. So what we tried to do in this paper was to pull as much of the literature on hazard interrelationships and quantification together and put it into a framework. There's a lot more that needs to be done in this, though. So multi-hazard approaches offer a holistic way to assess natural hazards, particularly when considering urban risk. We've identified interrelationships, both for natural hazards and for anthropogenic processes. We used a systematic approach. We tried to simplify a vast array of complex information in a way that practitioners and others might be able to work with it more easily. And we looked at dynamic vulnerability and exposure.